What if your Arduino could feel temperature the same way your skin does and react to it? With a tiny sensor like this one, the LM35, that is exactly what we can do. This small integrated circuit can measure the temperature around it and turn that into a voltage we can read with Arduino. In today's class, we will understand how this sensor works and build a project that reads room temperature and displays it in a smart way. Welcome to lesson 17 of our 24-part series called Arduino for Beginners. Let's start by understanding what the LM35 actually is. The LM35 is a precision analog temperature sensor IC. Unlike thermistors, it does not work by changing resistance. Instead, it has internal circuitry that produces an output voltage directly proportional to temperature. That makes it very convenient to use with microcontrollers like Arduino. This sensor can measure temperatures from about -50 up to 150 degrees Celsius, which is more than enough for most hobby and educational projects. The most important thing you need to remember about the LM35 is its scale factor. For every 1 degree Celsius, the output increases by 10 millivolts. That linear behavior is a huge advantage. It means we don't need complicated formulas or lookup tables. We can convert voltage to temperatures with a very simple calculation. Another big benefit of this sensor is that it does not require calibration in normal use. The calibration is done during manufacturing at the wafer level. According to the datasheet, the typical accuracy is around 0.25 degrees Celsius at room temperature and about 0.75 degrees Celsius across the full temperature range. That is extremely good for such a simple component. The module we are using today is very straightforward. It has 3 connections: VCC power, which can be 3.3 volts or 5 volts, GND, and the signal, which outputs an analog voltage. Since this is an analog sensor, we will read it using one of the Arduino's analog input pins. That is enough theory for now. Let's build something real with it. Before we continue, you might be wondering where to get parts like this. The LM35 sensor used in this lesson was kindly provided by the sponsor of this series, DFRobot. DFRobot is a global provider of hardware for makers, students, and engineers. In their online store, you can find sensors, modules, boards, and kits like the Mind Plus Arduino Code Kit, which we've been using throughout this course. This kit includes a wide range of components that make it perfect for beginners who want to follow along and build every project in this series. You can find the link to their store in the description below. Thank you DFRobot for sponsoring this series and help make STEM education accessible for everyone. Now let's get back to the build. Today's project is simple but very powerful. We are going to measure the room temperature with the LM35 and display it on an I2C LCD screen. But we will go a step further and make the system interactive by adding a push button. The system will start by showing the temperature in Celsius. When you press the button, it switches to Fahrenheit. Press again and you go back to Celsius. That's already a more professional user interface than just printing numbers. For this project we will need Arduino Uno, input-output expansion shield, LM35 sensor, I2C LCD module, push button, and a few jumper wires. First, attach the input-output expansion shield to the Arduino. Connect the push button to digital port 2, connect the LM35 signal pin to analog port A3, and make sure VCC and GND are connected correctly. For the LCD module, SCL to A5, STA to A4, VCC to VCC, and GND to GND. If you need additional help, follow the schematic that's appearing on your screen right now. Next, go to the GitHub repository for this course. The link is in the description below. Open the folder for lesson 17 and copy the file called read temperature. Paste it into the Arduino IDE. Before uploading, make sure you have installed the library DFRobot RGB LCD 1602. Now upload the code and observe the result. The LCD shows the temperature in Celsius. Press the button and it switches to Fahrenheit. Press it again and it switches back to Celsius. Simple but very effective. Now let's understand the code. At the top of the sketch, we include the required libraries and define our pins and main variables. We also create the LCD object. Inside Setup, we start serial communication, configure the button pin as input pull-up, initialize the LCD, store the initial button state, save the start timing using millis. Then we initialize our sample buffer. We take several readings from the LM35 and store them in an array. We also compute their total. This allows our average system to start with real data instead of zeros. In loop, we never use delay. Instead, we use millis to control timing. This is a professional habit that allows the system to do multiple things at once. Every 10 milliseconds, we remove the oldest sample from the total, read a new value from the LM35, add it to the total, move the index forward in the array. The line with the multi operator makes the index wrap around to the beginning. This structure is called a circular buffer. It lets us keep a rolling set of recent samples. We then compute the average reading, convert it to voltage, and finally to temperature. Since the LM35 outputs 10 millivolts per degree Celsius, we multiply the voltage by 100 to get temperature in Celsius. Fahrenheit is calculated from Celsius using the standard formula. This averaging reduces noise and makes the reading more stable. Next is the button logic. We ignore the button during the first second after startup to avoid false triggers. After that, we read the button and compare it to the last reading. If the value changes, we reset at the bounce timer. Only if the reading stays stable for more than 50 milliseconds do we accept it as a real press. When a stable low state is detected because of input pull-up, we toggle show Celsius. This ensures one press equals 1 unit change. Finally, we update the LCD only every 500 milliseconds. A static variable stores the last update time. Static means it keeps its value between loop cycles. We clear the line, print temp, and then print either Celsius or Fahrenheit, followed by the degree symbol and the unit. Serial printed is included for debugging. With the single sketch you are using, sensor filtering, no blocking timing, circular buffers, the bounce logic, state toggling. These are professional embedded programming techniques. Before we finish this lesson, I would like to share a quick announcement. I'm currently preparing a masterclass about building drones using Arduino. This masterclass won't be for complete beginners. You'll cover more advanced topics like flight control, wireless communication, energy management, PCB design, and 3D printing. The goal is to teach you how to build your first drone with Arduino step by step. If you are interested, I've created a waiting list and linked it in the description below. Sign up using the form and you'll be the first to know when the masterclass is available. That is the end of today's lesson. Today, you didn't just read the temperature, you built a smarter system that filters data, handles user input properly, and manages multiple tasks at once. If you enjoyed this video, subscribe so you don't miss the next lesson. And before the next tutorial comes out, check the video appearing on your screen right now. It will help you improve your Arduino skills even more. Thanks for watching and I'll see you in the next one.